Hello, everyone. Plan for today is we are going to cover a couple of dynamic programming examples. One of those examples is the shortest path problem that we saw earlier, for which we already have a couple of, well, at least a couple of algorithms, right? We did the Dijkstra, or actually more than a couple, right? Shortest path के लिए हमने Dijkstra देखा है. Um, in review sessions, you also saw BFS, which is also shortest path algorithm. You also saw a shortest path algorithm for directed acyclic graphs, so that also counts. And we saw one for negative weights, and it was called Bellman-Ford, right? After Bellman and Ford. Right, so we are going to see one more example, and this is going to be, actually Bellman-Ford is also an example of dynamic programming, but it's not very obvious example of dynamic programming, let's say that, okay? But we're going to see a very obvious example of dynamic programming on the shortest path problem for directed graphs, directed or undirected graphs. Before we start that, we are going to do a worksheet. Worksheet is also a dynamic programming example, so let's do it together, okay? I'm going to share the worksheet on my screen, and you are supposed to head to LMS to fill up your answers for this. Okay. Assume everyone can see this. ये वाला part is not. Where is the pen? This is the pen. ये वाला है ना? Okay, so ये वाला जो part है ये valid नहीं है. You are doing it individually. We are going to solve something called an added distance calculation problem. The kind of background of this problem is that you have two large DNA strings and you want to figure out whether DNA corresponding to one is one individual, one pathogen or whatever. Usually, I think this works for flu viruses, for which you want to figure out the strain of flu virus that is prevalent today. Is it related to DNA-wise, right? DNA-wise related to the flu virus that we had, let's say, a couple of years ago. Okay, so what you have is you have long strings of these alphabets. Alphabet is very small, usually 4 letters: A, adenine, guanine, cytosine, and thymine, 4 proteins. And you want to figure out how different these two strings are. And the difference is based on mutations. And the mutations happen in 3 different ways. One, that a protein is deleted from the DNA string. Second possibility is a new protein is inserted somewhere in the string. And the other possibility is a protein is switched somewhere else. Um, some protein is switched with some other protein, swapped, okay? So these are 3 different kind of mutations or changes that can happen. So here's our problem for strings. Forget about all the DNA thing. You're given 2 strings and you have to do these 3 operations. One, you can insert a new character into string. Second, you can delete a character. And the third one is that you can switch a character with any other character that you want. And your goal is to transform one string into the second with minimum number of operations. Okay, and the algorithm you're going to write down is going to tell you the number of operations required. And of course, we are looking for a dynamic programming solution. I hope the problem is clear so far. All right, assuming it is. So in the warm-up exercise, you're given strings examples, and your goal is to figure out the distance between these 2 strings. First pair of strings is kitten and sitting. So you have to change letters in the first string so that after a bunch of operations, you get the second string out of it, okay? Um, let me know if you are having trouble somewhere, okay? Or not either. Let me know if you're done with the first question. Any questions? Raise hand if you're totally lost. Okay, San Farhan is totally lost. Okay. Wow, that's a very small number of people who are totally lost. That's great. I'm so happy. Can you do one as an example? Yeah, okay, let me do the one as example. Okay, I'm gonna do the first one as an example. Okay, so right, so I have to change kitten to strings, seating. Okay, without attempting any kind of systematic algorithm on it or thinking about it, I see that there are few letters which are common in both of them, and they are in the specific order as well. Okay, so what I see is that I, T, T. What's wrong with my writing today? Okay, so these three. I just this table. Okay, so I, T, T, and N seem to be common in these two strings, right? So I would ideally want कि इन letters को मुझे change, delete ना करना पड़े, okay? So what I could do is I could delete K, okay? So D for, let's say, delete. I'm gonna delete K. The K is gone, and then I'm gonna insert S. Oh, I could just transform K to S, right? So let me not delete K and insert S. I would just transform sorry, replace K to S. Okay, so here's my first operation. First operation is move, replace K with S. Okay, I am gonna keep as is, T I'm gonna keep as is, T as is, and then I'm going to transform E to, you guessed it, I. Okay, after these two transformations, my first string is looking like this. S I T T I N. Right, that's it. Okay, so at this point, I think you're pretty, this is pretty obvious that you want to add or insert G at the end. Okay, so if I do that, I will have the second string with me. Okay, which means that I'm 1, 2, 3. 3 is the distance between string A and string B. Okay, in 3 operations, I can do it. This is the minimum number of operations that can change kitten to sitting. Okay, so that's not the only way to do it, right? There could be multiple different ways to achieve this added distance. Go ahead, try the second one or the third one or the fourth one. I hope it's clear now. Nisam. All right. Okay. You can definitely add a character in the beginning. Everything is allowed. So insert mean insert a character and wherever you like. You can add it anywhere you like.
Sir, I have a question.
Sure.
Sir, when we delete a character, are we treating it like a stack? यानी कि flaw में से मैं F को delete करता हूँ, तो now can I assume that the first character is L?
Yes, absolutely.
Okay,
Yeah.
thank you.
Once you delete a character, it's gone. It's nowhere to be found. The next letter will take its place. Cool. Any other questions? All right. Are we done with the second example? Thumbs up will do. Okay. Okay. Cool. Let's try third, fourth. So worksheet is not uploaded anywhere. You have a worksheet 8 in LMS where you can write your answers. Right. Okay. So are we done with first question? Are we done with this question? Okay. Mariam is done. Okay. Anyone who wants me to wait more for them to complete question one, please raise hands. Okay. 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 All right. I'm gonna wait a couple of seconds. Can we make the word from both side? I have trouble understanding this question. Can you rephrase, Bilal? Okay. So he's saying that do I have to go from A to B or can I go from B to A if that's what he means? So मेरे ख्याल में there is no difference. You would get the same distance. The वो जो let's say if you have to do um a replace, two deletes, and one insert to go from A to B, then you would have to do exactly all four operations in the opposite direction. So for example, if you had to do two deletes, you would have to do two inserts in that way. Okay. So if you can go in four operations from A to B, you can definitely go in four operations from B to A. So either way, whichever you feel is easier to do, you can do it. Distance, wherever you hear the word distance, you would um, distance is a measure that's um, commutative. Okay, so distance from A to B is usually distance from B to A, wherever, most in most of mathematics. Okay, unless you define distance in a different way, distance is defined as a measure that's non-negative, and it's the same from A to B to and B to A. Anyone has a question?
Sir, is it a safe assumption that most optimization problems like minimum or maximum can be solved using dynamic programming?
Um, for okay, so question आप सब लोगों ने हेयर कर लिया मैंने मुझे रिपीट करने की जरूरत नहीं है पर for most optimization problems DP works only if you can find optimal substructure and you have overlapping subproblems. Overlapping subproblems near the DP will not help you at all. Okay, so you have to look for again an optimal substructure, and you have to look for overlapping subproblems. ये दो conditions are wherever you can find them, you will you have a chance to implement a DP there.
And similarly, I had noticed another thing, कि जो combinations and permutations type problems हैं, they usually have this kind of substructure property. Are they also usually like dynamic programming type solvable problems?
अमन ये कोई अम, मैं ख्याल में ये कोई इस तरह का फार्मूला नहीं है कि आपके पास परम्यूटेशन कम्बिनेशन टाइप प्रॉब्लम्स हैं तो यू फॉर एग्जांपल जो जेनेरिक कम्बिनेशन और परम्यूटेशन की प्रॉब्लम्स हैं यस उसमें एक ऑर्डर भी है उसमें मेक सेंस भी करता है फॉर एग्जांपल इफ यू वांट फाइंड आउट द कम्बिनेशन ऑफ अ सेट राइट उस केस में जो उसका रिकर्सिव सॉल्यूशन है उसके अंदर you have a pattern that you have overlapping subproblems वो हो रहे होते हैं do you have any other problem in mind just so एक तो है generic you want to find all combinations of a fixed size for a set that I understand do you have any other problem in mind जिसके लिए which is combination type for example जिसके लिए DP apply होना चाहिए मेरे ध्यान में तो नहीं आ रही
Yes, sir. I can also only think of like finite set wali problems. I
right
can't really think. Yeah.
क्या All right, let's hit the second question. You can already see it. So the goal is you want to find out the core of DB, which is that how you define your state um, at a distance of ij. So which means कि आपका जो DB का state होगा वो two dimensional होगा. You have to find out uh, what would ij cell represent in that table. Um, uh, Somewhat straightforward, I guess, based on what we have seen so far. मेरे ख्याल में वो जो वाइल्ड कार्ड मैचिंग वाली प्रॉब्लम थी उससे शायद थोड़ा बहुत इंस्पिरेशन ले सकते हैं to solve this. So the goal is to figure out what should I at a distance of ij represent. Can anyone? I see few questions in chat. Let me just go there. It could mean if they are same. Okay. Hmm. So अगर ये करोगे ना तो फिर थोड़ा सा so do you mean that the ith character and the jth character are same or not? Haris says that it could mean that. Oh, right. So देखो from this table you have to extract the answer. राइट रिमेंबर डीपी की स्टेट के अंदर जो लास्ट वाला कैरेक्टर होता है या फर्स्ट वाला कैरेक्टर होता है ना दैट्स गोना बी द आंसर टू योर कंप्लीट प्रॉब्लम एंड योर कंप्लीट प्रॉब्लम इज टू फाइंड आउट द डिस्टेंस बिटवीन एम एंड ए सो एट ई ये वाला जो टेबल है इट हैज टू डिफाइन एट ए डिस्टेंस in that terms. Okay, so um, this matters definitely whether ith character of the first string and the jth character of the second string match or not. This definitely matters. But but that's not the only thing that matters, right? Because you have to yeah, Zerman has the right idea. Okay. Yeah, I'm not gonna say go see it in the chat if you have to. Okay. Um, right. So ultimate goal is that that ultimate goal is that ed of the first string has m letters. So ed of m and ed of m comma n should be equal to the added distance, right? Of the two strings. ये अभी आपने डिज़ाइन करना है तो सिर्फ ओके ये अभी हमने completely डिज़ाइन नहीं किया अभी मैंने डिफाइन किया है कि what state of your DP is going to look like. ये आप कैलकुलेट कैसे करेंगे this is not clear yet. Okay, we're moving to that part. All right, guys, I'm going to question number 3. I might have missed some of the questions. Okay, you guys can unmute yourself if you feel that your question was not answered. All right, based on what we have defined the added distance dp state, you should be able to fill up this table now. Okay, I will invite people to answer. Let me just say, yeah, the fourth part. Fourth question मेरे ख्याल में आप इस थर्ड से पहले आंसर कर सकते हैं. So given that ed of I comma j represents the added distance of the first I letters of the string A and the first j letters of string B, what should be ed of I comma 0? Right, right. Okay. Yeah, it should be I and it should be j, right? It should be I. That you want to remove all letters to get to an empty string. You have to transform a string that contains I letters to a string that does not contain any letters. So all you have to do is remove all the letters. Okay, so that's what it is. Second case may you have to transform an empty string to a string that contains j letters. Okay, so what you need to do is you need to insert j letters. In that case, Marine, do you have a question? Can you repeat it? I guess not. Okay, so
Sir,
क्या
sir, the way we define our base cases, उससे इस चीज के ऊपर फर्क नहीं पड़ेगा जो हम लोग पहले बात कर रहे थे कि हम A स्ट्रिंग को B में कन्वर्ट करें या B को A में,
राइट क्या
तो फिर वो स्पेसिफाई हो जाएगा.
तो और जो उससे फर्क पड़ेगा ना वो सिर्फ और सिर्फ इस चीज का है कि do which operation you use. Do you use insert or do you use delete? The number of operations वाला part पे कोई फर्क नहीं पड़ेगा. That should remain same.
ओके.
Okay? क्या so उस केस में ये होगा कि instead of I deletes you would get I inserts, and instead of J inserts you would get J deletes. All right, I think you guys have enough information to fill a table in problem 3 now. Go ahead. Yeah, partially, I guess. Okay. Let me know if you're done with problem 3. All right. So this is your string A, and this is your string B. There's no cost of changing, transforming a string with no letters to a string with no letters. So this must be 0. ये हम decide कर चुके हैं. It will be 1, 2, 3, 4, and 5. Similarly, this will be 1, 2, 3, and 4. Okay. Up you have for this cell, you have a string that contains C, and you have to transform it into a string that contains S. People who are done with problem 3. People who need help with problem 3. Okay. What do we do? Can anyone shout out what should be in the circle? What should be at place 1, 1?
1.
Yeah. You need to transform C to S. Great. What about 1, 2?
1.
1.
One.
Right. Yeah. Because all you need to do is you need to insert a letter S, or delete if you're going from B to A. All right. I think I'm gonna leave it at that because I think the concept is pretty clear. You just need some time to fill up the table. Okay. You can go back to this question when you have when you have more time. Okay. I'm gonna give you more time. We are moving to next question, unless someone has a question to keep me in question 3. All right, I think we're good. Okay, so next question is to write the recurrence for the two cases. One, so recurrence is for ed of I comma j. So you now have to write down ed of I comma j in terms of at a distance of smaller strings, right? And this is going to be different depending on whether the letter I is equal to j or not. Okay. This is the first case. The other case is when it's not. Um, any ideas? I think the first case is somewhat easier. If you have two letters matching, as for example in this case, ये वाले केस में मैच कर रहे थे, right? How do we find out that it's gonna be one here? So ed of, let's be specific, right? At a distance of 1, comma 2. This is my shorthand, so this is just ed of 1 and 2 is equal to ed of 0, comma 1. Right. Yeah. Right. Okay. So in this case, it's ed of I minus 1, comma j minus 1. Okay. Okay. What happens if they don't match? What do we do? Again, look at this table.
So we take the minimum of the upper row or the left column and then add one to that.
Right. So here is a proposal that you take minimum of, so you add 1 because they don't match, and then you take the minimum of ed, comma I minus 1, comma j, or ed, comma I, comma j minus 1. Is that all? Yes. If the characters do not match, we must perform an operation. And we can perform 3 operations. I minus 1, comma j represents inserting a character. I, comma j minus 1 represents deleting a character. You also have a third option, which is to replace that character with another character. And that is the diagonal value. Okay. All right. I gave you the solution. Let's not talk more about it. This one is, I think, something that you guys should be able to handle. Okay. So I gave you the recurrence. Now the goal is to figure out. So what recurrence does is it fills up this table. Okay. And how long does it take for it to fill up this table if you write it up in for loops? Um, oh, no. Abdullah says O of n. No. Okay, let me just write down the algorithm for it. Okay. So this is my recurrence. What is my algorithm going to look like? So I'm gonna declare this table ed. In the beginning, it's gonna be empty. Okay. उसके बाद मैं करूँगा for I goes from 0 to n. I'm gonna fill up ed of I comma 0 to be equal to I, right? So that's the ये कौन सा वाला part है? ये base case है ना? Similarly, I'm gonna have a for loop which goes from, I don't know, j to j0 to m, or array distance of 0 comma j is going to be equal to j. All right. Can I show question 5? This is what question 5 looks like. All right, let me keep question 5 on the screen. Acha, this is my initialization. Uske baad I have to loop through everything again. But now I have to start from I is equal to
पॉइंटर्स सोच जा ताकि आगे बताना होता है पूरी दुनिया से तीन बच्चे
Cap.
से हसद करते हैं तो वो काम रुक जाते हैं
Cap, can you
पर
turn on?
एक लड़की थी डीपीएस की थी उसकी और उसके भाई की हुई वीडियो वायरल वो वाली जिसके अंदर वो
Cap भाई
ब्रेक योर आउटफिट कॉस्ट वाली
यार इसको म्यूट कर सकते हैं हम. All right, okay. For I goes from 1 to n, what do we do? Okay, give me a second. पानी कहाँ है मेरा यार? मैं तो मैं पानी भी पी सकता हूँ. Okay, so हमने फर्स्ट रो और फर्स्ट कॉलम को फिल अप कर लिया. Now my I is gonna start from 1 instead of 0, and my j is going to start from 1 and will go up to m, and we have to fill up ed of I comma j using the same rule जो मैंने यहाँ पे लगाया हुआ है. Okay, so it's going to be equal to ed of I minus 1 j minus 1 if I'm in this situation. Okay, so if a of I is equal to b of j, else it's going to be equal to minimum of a bunch of things. So the formula is going to look like ed of I comma j is equal to 1 plus minimum of 3 things. और वो 3 चीज़ें मैंने ऊपर लिख दी हैं आपके लिए यहाँ पे. Okay, just put them here. Okay, cool. So this is your algorithm. Can someone shout the time complexity for this algorithm? Right. Yeah. Omar, you can write it in any way you like. You can write it the way I wrote, or you could just write it in a couple of English sentences. Okay. Anyhow, I think you guys have pretty good idea about the complexity as well. I think, Zainab, what's the deadline for the worksheet?
3:45 है अभी deadline.
Oh, okay. Okay. So you have about 30 minutes even after the class. But I assume that you guys should be done by, I don't know, next 5 minutes or so. Okay. You already have answers for all the questions. Should we move on? Any questions? Right. Yeah. Sharo says the correct answer. Space complexity, Wase, is the size of the table. And the size of the table is m times n. It's not m plus n. Right. Any questions? All right. I think we can move on to the shortest path thing. Okay, I can probably motivate it right here. So the shortest path problem that we have seen so far is that you're given a graph. The graph is weighted, and you're given 2 points. I mean, that's a typical situation, navigation की जो आपकी apps हैं, Google Maps, Waze वगैरह के अंदर. And you want to find out a shortest path from point A to point B. And Dijkstra solves it for you, Bellman-Ford solves this for you. But what happens is that for a given graph, for a given city metropolitan area, your app usually gets millions of queries. Okay, so for example, Lahore, अगर आपको 1 सेकंड के अंदर 10 लाख दफ़ा डायस्ट्रा चलाना पड़ जाए या बेलमन फोर्ड चलाना पड़ जाए, so that's a big deal for your infrastructure. That's gonna require serious scaling. So what sounds like a more appropriate approach for this scenario is that you divide your city into a bunch of nodes which are fairly close by to each other, and then you pre-compute the shortest distance between all pairs of nodes. Okay, that's gonna be a huge task. It's gonna probably take days for your computer to compute shortest path for all pairs of nodes in a city. But what's going to happen is that after you have pre-computed them, answer to every query is just constant time. You just need to find out these are the 2 nodes I need to find the shortest path for, and you go in your data structure, which is usually a table, and you go to a particular cell and you find out the shortest path between point I and point J, and you return it in constant time. So that sounds like a more reasonable, more scaled version of a practical shortest path algorithm. And that's what is the problem that we want to solve with dynamic program today. Okay. So again, what is given to you is, let me just, can I add a new page here? Okay, so you're given a graph. Okay. Again, graph के ऊपर हम कोई assumption नहीं लगा रहे. It can contain negative weights on edges. Okay. Whatever its motivation be, and you want to find shortest path. आज जो हम problem crack करने जा रहे हैं, it's not shortest path, it's the distance. Okay. You want to find out the distance between every pair of nodes or vertices in the set V. Okay, so again, W is a set from Rails. Okay, so it can be negative. So anyone who has not seen the algorithm, any idea how you would approach it using dynamic program? How would you do it via dynamic program? Remember, dynamic program के लिए what you need is optimal substructure, right? You want to be able to create subproblems and solve the original problem using solution to your subproblems. Okay. Or design a DP is another way to say define your state. Okay, what is that thing that you are going to store in your memory? Okay, or इसको memo भी कहते हैं आप. Okay, all right. ये कहने से पहले, before I tell you what the state is, remember the answer to your problem. You have to find the distance between every pair of nodes in V, which means कि जो आपका answer होगा, उसका जो format होगा, it's gonna look like a matrix. Okay, it will be a matrix of size V comma V, right? Because you have to find out shortest path distance between every pair of points. और इसके अंदर for example इसका नाम मैं क्या रख दूँ? Distance matrix रख देते हैं इसका नाम, okay? So D of I comma J would represent, this is not state, this is the output. ये हमारी output होगी, okay? D of I comma J would be the distance from node, let's say Vi to node Vj, okay? Directed graph hai, so the distance from Vi to Vj could be different from distance from Vg to Vi, okay? It nullifies what I a moment ago said about distance. Anyhow, okay. Cool. Okay. So this is what what's gonna be the output of your algorithm. Okay. अब आपकी स्टेट के अंदर कहीं पे ये पूरी की पूरी मैट्रिक्स पड़ी होगी, राइट? रिमेंबर स्टेट के अंदर किसी कॉर्नर में जो चीज़ पड़ी होती है दैट्स गोना बी सॉल्यूशन ऑफ योर प्रॉब्लम, राइट? तो स्टेट आपकी is going to be slightly bigger than a two-dimensional array because two-dimensional array is going to sit somewhere in there, okay? And you're going to compute a two-dimensional array based on some other two-dimensional arrays. Does this make sense? That's what DB is, right? You compute solutions to a problem based on solutions to some sub-problems, okay? So you have to define D as a state in a different way, okay? And the definition is, anyone has any ideas for the last part? Can we just simply write the complexity? Oh, okay, you're still stuck at the worksheet. Okay. I hope you guys are still hearing what I'm telling you about the shortest path. Anyhow, okay. Cool. So, right. So, I'm gonna define my state to mimic shortest path distances or distances between pairs of nodes that only use a specific set of nodes. Okay, so my subproblem is going to look like find shortest path. That's not how you spell shortest path, right? Find shortest path again from I to J using only a subset of vertices as intermediary nodes. Okay, so that's going to be my subproblem. I'm going to find the shortest path from I to J, but I'm going to use some of the vertices to find the shortest path, not all of them. Okay, and my DB state formally is going to be, I'm going to call it K, index by K. Remember it's a two-dimensional array. Okay, so I'm going to define Dij as the distance from I to J that only uses first K vertices. Algorithms may study some algorithms which are like totally out of the blue, that you think you will never be able to come up with them on your own. This is not one of those algorithms. ये उस तरह का algorithm है that if you read it और उसके बाद आप बैठ के सोचें, you feel like you could have come up with this algorithm on your own if you had, I don't know, a couple of days to yourself. Okay, so let's read this state again. Okay, so my state is going to be distance from a node I to a node J that only uses first k vertices. Okay, so अब k को आप यहाँ पे लिख सकते हैं. You can write it again Dijk like this. First of all, if I ask you the question, what is this thing when k is equal to 0? What would you say? Anyone? What's the distance between I and j if you're not allowed to use any other vertex? Anyone? Bilal, is that an answer to my question or Michelle's question? Right. Yeah. So Naufal says that it should be equal to, like, we go directly from I to j. Yes, Bilal, that's what it is. Yeah. So if there is an edge from I to j, then that's what it is, right? If you can go directly from I to j without any intermediary vertices, then the weight of that edge is the distance from I to j, right? So if right, it's gonna be weight of I comma j. If there is an edge, and if there is no edge, this is going to be positive infinity, right? There's no way you can go from I to j if there is no edge between them. Is this clear to everyone? Do I need to? Let's say, let me make a stupid graph here, okay? So let's say this is my graph. For some reason, I end up with the same graph every time. Do I want to? Yeah, let's do it. Okay. A, B. I actually should use numbers here because I'm using I and j for vertices, right? Index कर रहा हूँ मैं उनको. So let me remember them. 1, 2, 3, 4, 5, and 6. Let's say इनका weights जो है वो है I don't know, 10, 5, 10, -4, 3, -1, 2, 0. Okay. So just to be clear, distance of 1 to 6, 0 is going to be infinity. And distance of 1, 3, 0 is going to be 5. Okay. Make sure that you understand why the first one is infinity and the second one is 5. Okay. All right. So let me do the second one. So Dij, 1. So now you want to go from I to j, and you can use 1 as intermediary node. Okay. इस केस के अंदर Dij, 1 is gonna be just Dij, 0, because there is only, right, there's no path from between any pair of vertices that goes through 1. Okay, but इसको define कर लेना चाहिए आपने sign कर. Okay, so this is the distance from I to j that may use, is allowed to use vertex 1 or vertex v1, I don't know, as somewhere on the path, right? Intermediary. Okay. This is a keyword here. Okay. All right. So now we have defined the state. We know what our subproblems look like, and we know what dij of 0 is, and we know that our problem has solution which lies at dijn. Okay. So when we say that we want to find out shortest path from I to j, we actually mean that we want to go through any of the vertices of the graph. We want to find the shortest path, right? So dijn, which is saying that find the shortest path, use any of the first n vertices. Is saying use whole graph to find the shortest path, right? So this is my answer. This is where my answer looks like. All right. So I have defined the state. Now I have to find out the recurrence. Okay. So I want to find out dij k in terms of smaller values of ij k, or k actually, right? Any clue? Any help from anyone? So I said this may is the keyword here, okay? Which means that there are two cases. One, I'm going to use vertex k specifically, okay? और एक ये केस है मेरा, और दूसरा केस है कि I'm not going to use, do not use vertex k, okay? The second case is easy. What if I'm not gonna use vertex k? What is my dijk then? Any questions? Do you want me to go back somewhere? Is the kth k the number of first k vertices or the kth vertex? Right. So dijk is, I think it's a very important point जो Bilal ने भी raise किया. How do we define Dijk? Dijk is defined as the distance from I to j that uses the first k vertices. Any of the first k vertices, okay? So any of the, इसकी जो definition है ना, it's any of the vertices v0 up to k, okay? Okay, 0 to k or 1 to k? 1 to k, okay? 1 to k. Okay, so let's say मेरी vertices जो हैं, they are labeled from 1 to k. They're gonna be slides, don't worry about it. We're gonna go through the slides. But I just want to make sure that we understand it while we are trying to figure out with the solution. Okay, so when I define the IJK, it means that I'm gonna use any of the first k vertices. I have to figure out a way to write this down as a recurrence, right? I want to find out the IJK in terms of dijk minus 1, for example, okay? How do I do it? What do you think is natural when I do it? And I told you there are two ways to do it. One possibility is that I use the vertex k to go from I to j, and the second possibility is I do not use the vertex k to go from I to j. Right? If I do not use the vertex k, in that case the recurrence is pretty simple. Can anyone? Oh, Sharia says that if I'm not going to use the vertex k, so remember, जब मैंने यहाँ पे कहा dij means that you are allowed to use any of the first k vertices, okay? उसके बाद मैंने कहा कि you are not allowed to use the vertex k. It does not mean that rest of the vertices are also forbidden, okay? So it limits the set of allowed vertices, and it kind of excludes the kth vertex from there, okay? So you are still allowed the first k minus 1 vertices, okay? So does that mean that I have an answer for Dijk for the second case? What is going to be? Right. Bilal, थोड़ा सा इसको और elaborate करो. He's saying k minus 1. But what is it? It's equal to, right. Yeah, 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 yeah. Now people get it. So it's, if I'm not using I'm allowed to use k first k vertices, and I'm not allowed to use the kth vertex, then Dijk is just Dij k minus 1. Okay, which hopefully I have already commuted using recursive method या जो भी मैं कर रहा हूँ. Okay, dynamic programming. Okay, so in this case जो second वाला part है वो तो आसान हो गया. Okay, अच्छा, first case का मैंने अभी figure out करना है कि what the answer is gonna look like. Okay, so what happens in the first case? फर्स्ट केस में मैंने फिक्स कर दी कि यू हैव टू यूज द kth vertex now. Okay, अब वो मे वाला पार्ट नहीं रहा. Okay, I have removed the uncertainty there. You have to use the kth vertex now. The path from I to j must go through k now. Okay, in that case, what is it? What is dijk? If I have to go through, oh, Arif says that it's dijk minus 1 plus the weight of the edge. So let me just try to go back to this picture. Okay, so let's say I'm looking at the 1 6, so I want to go from vertex 1 to vertex 6, and I'm saying that k is 2, that you must go through 2. Okay, so what should it be? So Dijk minus 1 represents a path that excludes vertex 2. It does not go. There's some path जो यहाँ से मैं थोड़ा सा messy कर दूंगा इसको, but let me do it anyway. Okay, that uses some vertices in some way. I don't know how it does, but it starts at 1, goes to 6. It does not use 2 as a vertex as well. Adding k to, or value of k, I mean, to a does not make sense to me. I mean, this is the ijk minus 1, right? If I must go through 2, what would be my distance? Any other ideas? I'm going to tell it to you and you're going to be, I knew it. So I'm just going to give you a chance to become a superhero. If you must go through k, how about I actually go to k from, somehow go to the kth vertex first. क्या 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 That's the answer, Bilal. That's the answer. Awesome, cool. So that's the answer. That you, this is, let's say, your vertex I, and this is your vertex J, and there is somewhere along the way a vertex K. This thing is telling you that somehow go to vertex K, and then go to vertex J. Okay, and this part must be the shortest path from I to K, and this must be the shortest path from K to J. Okay, let me write it down and let me then ask you guys if this does not make sense, and I'll repeat it then. Okay, so इस case के अंदर this is going to be D I to K using the first K minus 1 vertices. Okay, and then D K to J using again the first K minus 1 vertices. Okay, so shortest path from I to J that goes through K is the shortest path from I to K, and the shortest plus the shortest path distance from K to J. Okay, awesome. Questions? And the shortest path from I to J is gonna be minimum of these two. Okay, so you only have two possibilities. Either you go through K or you do not. On both of these cases के लिए हमने we figured out what the answer is, right? So you take you figure out these two values which are already computed, right? And then you find the minimum of them. Any questions? It's super simple. To me, this sounds like that you know, if someone gives this as an exercise to you, you will probably be able to come up with this. But still cool too, right? You find uh, this to be worthwhile. You do it and you feel you've done something nice. Any questions? Why do we dive into using kth vertex and not use the kth vertex, given k is originally just a number, not a reference to a vertex? So by k, I mean the kth vertex, first of all. Let me know if I answer your question here. तो फिर मुझे बताइएगा, I'll try to answer it again if I did not understand it correctly. But so the thing is, यहाँ पे ना, if you look at this graph, okay, let me try to find an example. Cool. So think of the I specific करता हूँ मैं इसको D165. Okay. You want to go from 1 to 6, and you are now given a choice to use the vertex 5. Okay. I mean, इसका मतलब ये है कि you can use any of the first 5 vertices, but you already know the answer to D164. Okay, you have already computed the shortest path from 1 to 6 that uses the first 4 vertices. Acha, now you are saying, okay, I'm going to allow you to use the vertex 5 as well. But if you look at the graph, you see that using vertex 5 does not help. If you use the vertex 5, मुझे अगर यहाँ पे मैं पढ़ सकता हूँ, oh, इस case में it helps. Okay, let me just green में इसको मैं 10 कर देता हूँ. Okay, so इस case में, if this is 10, if I go from 1 to 2 to 4, and I force myself to go to 5, तो फिर my answer is gonna be larger. Okay, so इस केस में मैं थोड़ा सा इसको मेसी कर दिया, थोड़ा सा erase कर देता हूँ इस पार्ट को. Okay, so this is gonna be a minimum of two things. One, that I force myself to go to 5. Okay, if I force myself to go to 5, then my answer is first to go to 5 and then go from 5 to 6, right? तो वो दो पार्ट क्या बनते हैं? So if I have to go to 5, I would have to go to 1 to 2 to 4 to 5, which is gonna be 10 minus 5, which is 5. Okay, so ये है मेरा D of 1, 5, 4. Okay, go to 5. using the first 5 vertices. Plus, I have to go from 5 to 6 now, which is 10. Okay. So ये दोनों पार्ट मिला के मेरे पास 15 बनते हैं. अच्छा, सेकंड ऑप्शन ये है कि I do not use 5 vertex. Okay. उस केस में मेरा जो आंसर बनेगा, it's gonna be 10 plus -4 plus 2, which is 8, right? 8. And this is D of 1 to 6, 4. और ये मेरे पास already computed था. You'll see that this turns out to be 8. Okay, so at times a new vertex that's given to you to be used as an intermediary vertex on a shortest path is useless. There's no point. It does not help you find the shortest path. Okay, so at times it happens that you already have the shortest path using the first 4 vertices. Adding a new 5th vertex does not help you reduce the length of the shortest path. Okay, but you still have to check whether it helps or not, right? So you get 2 cases. One, that you assume that using it will harm or will not be useful. एक वो वाला केस है, और दूसरा वो वाला केस है जब वो यूजफुल है, उसको यूज करना चाहिए. तो what you do is you take the minimum of both of these cases.
That makes sense. Thank you, Professor.
Okay, cool, sure. Any other questions? What if J is equal to K? तो कोई खास फायदा नहीं होगा उसका, right? So I and J is or when I say the D, I, J, K, the source and the destination are already allowed. You are allowed to go from I. You are allowed to use I, and you are allowed to use J. Okay? So तो अच्छा, जब आप J equal to K करें, तो what you're saying is you are using the first J vertices. Okay, so D 1, 4, 4 means that go from 1 to 4 and you are allowed to use first 4 vertices. इस case में D1 4 is just D1 4 3. Okay, क्योंकि first word I mean ith vertex and jth vertex are already allowed by default. I hope that helps, Bilal. Okay. Any other questions? So that's kind of I find this algorithm to be super nice, simple and nice. Okay, कुछ होते हैं algorithm होते हैं जो आपको impress करते हैं. For example, the median of median algorithm is I'm impressed by median of median algorithms, but I don't think I could come up with median of median algorithm. Okay, that requires a serious thought. That is a PhD thesis. This one is not. This one is simple. This is किसी अच्छी जगह के ऊपर. This is an exercise. This is an algorithm exercise that students should be able to solve. But it's nice as well, right? Enough advertisement of this algorithm. So writing this algorithm is super easy. It's just based on this recurrence. So what you do is you initialize your algorithm like this. This is your initialization step, okay? So this is your initialization step. Initialization step. और उसके बाद what you do is you have 3 for loops that give you. Oh, I have slides. Let me show you the slides. Okay, I'm gonna share the slides from here. Where are my slides? They're not my slides. Okay, they are here. Replace current share. Okay, can you see my computer now? I hope you can. Okay, cool. Cool. So let me just get rid of this part. Okay, so right. So this is the problem statement. We went through this. How do I get rid of this? Okay, cool. So, right. So if a vertex is not reachable, if there's no path from U to V, we define its distance to be positive infinity. नेगेटिव साइकिल एग्जिस्ट करता है तो उस केस में नेगेटिव इन्फिनिटी है. मूविंग ऑन. राइट, दिस इज द रिकरेंस जो अभी हमने फिगर आउट की है. लेट मी मेक श्योर कि ये वही है जो हमने की है. Right. So in both cases, what we are doing is we are using the previous matrix, which gives you shortest path using the first k minus 1 vertices. It has two cases, one I comma j. This is the case where you are not allowed to use the kth vertex. Or second case is dik plus dkj. This case means you are forcing yourself to use the kth vertex. And your answer is going to be the minimum of these two values. And that's it. That's your recurrence, and this gives you an algorithm, which is this free for loops. Okay, so you initialize yourself like this. Oh, this is actually cuter than I thought. So you initialize your dii to 0. Okay. Okay, थोड़ा सा मुझे मेसी लग रहा है यहाँ पे. Okay. Going from a vertex to itself is 0. Makes sense. How do I... okay, cool. वो जो initialization वाला step था ना, that's the initialization step. Okay, so what you're doing is you are just initializing your matrix with the weights जिनसे आप start with. Okay, so that's the initialization step. उसके बाद this, I'm just trying to figure out whether this is necessary or not. मैं assume कर रहा हूँ कि this information is already in the W matrix. Okay, so मेरे ख्याल में ये line नहीं होनी चाहिए यहाँ पे. Anyhow, okay, so next three lines are the recurrence implementation जो हमने की है. So this is the line which says that if using the kth vertex I can come up with a better shortest path, then I should do it. Okay, so dij means that I'm not using the kth vertex. The distance remains the same, which I had in the k minus 1th matrix. But if I can figure out a way to go from I to j using k in a shorter way, then I'm going to update my dij. Okay, this is the implementation of that recurrence. The algorithm is called Floyd-Warshall, after Floyd and Warshall, and the time complexity is super easy to see. It's just n times n times n, which is n cube. And what you're doing is you are only maintaining one matrix. So your space complexity is n square. That's it. Any questions? How are we doing on time? We are on time. Any questions? Yep, you can draw on my screen. Okay, I can see your drawings. It's not just you. Everyone is seeing your hello. Okay, I guess that's it. Again, I like this algorithm. So go study this algorithm. I think we will spend one more day on dynamic programming on Monday. एक आधी एक्सरसाइज मैं कर लूँगा, एक आधी एक्सरसाइज आप लोग कर लेंगे. And then we will start the NP हार्डनेस वाला पार्ट. ओके, वो वाला पार्ट आपके लॉन्ग क्विज 2 में नहीं होगा. So dynamic programming is the last topic that's going to appear in your long quiz 2. We're running out of time. If you have any questions, तो Slack के ऊपर post कर लें. मुझे tag कर दिया करें अपने questions में, so I'll try to get to you. Also tag TAs. They work really hard for you guys on the background. Okay? They don't show up that much on the front, but they are working really hard to help you figure out algorithms. All right, that's it. I see you on Monday, I guess. Allah Hafiz.